Good morning, students. Today we are going to discuss about the first exercise of Database Management Systems Lab. Okay. So as we all know that already we have discussed about what is a database, what is a database management system, etc. And today we are going to do the first exercise. So exercise number 1, creating and managing tables. So first we'll see what is a query. A query is a statement requesting the retrieval of information. And there are 4 types: DDL, DML, DCL, and TCL. That is data definition language, data manipulation language, data control language, and transaction control language. And um, most widely used query language is SQL, or structured query language. And as we have already seen, the components of SQL are data definition language, data manipulation language, and transaction control language, and finally data control language. And what is this data definition languages? These SQL commands are used for creating, modifying, and dropping the structure of the database. So please try to remember that this DDL, data definition language, these are the commands that are used to create or define the database objects. Okay. And the commands that belong to DDL are create, alter, drop, rename, truncate. So these are some of the DDL commands. And then comes the data manipulation language. This SQL commands are used for manipulating the data, that is storing, retrieving, modifying, and deleting the data. The commands that comes under this data manipulation languages are the select, insert, update, and delete. Next one is transaction control language. This SQL commands are used for managing changes affecting the data. These commands are commit, rollback, save point, etc. And finally, the data control language. These commands are used for providing security to the database object. So whenever you're creating a table, you are the owner of the table, and only you can access the table. Nobody else can access the table. DBA can access, otherwise other people cannot access the table. And if others wanted to use your table, then you have to grant privilege to that table, to the user, those who wanted to use that. Okay. So only then they can use the table. So for granting privilege, we have a command called grant. And after some time, if you want to take back the privilege, then you have to use the command called revoke. Okay. And for today's lab, actually, we are mainly going to discuss about DDL. That is create, alter, drop, rename. So such commands we are going to use it. Okay. So one by one, we'll discuss. As I said, mainly we are going to discuss about DDL today, data definition language. And also you should know about what are the different data types. So there are different data types that are available. One is we have numeric data, we have character data, as well as we have date or time data types, as well as we have large object data types. So these are all some of the data types that can be used with this DDL or with your SQL. And before going to see, actually today we'll see how to create a table. After creating the table, if you wanted to alter, if you wanted to do some changes, okay, how to do that. So those things we are going to discuss. Before that, we'll see what is a constraint and what are the different types of constraint. So what is a constraint is, a constraint can be an arbitrary predicate pertaining to a database. Okay, so predicate means some constraint, some conditions, and levels at which constraints can be declared or at column level or in the table level. And the different types of constraints are primary key constraint, foreign key constraint, unique constraint, check constraint, and not null constraint. And as we all know that this primary constraint, okay, so it is unique as well as not null. Okay. Then we have that referential integrity constraint or the foreign key constraint and unique constraint. Okay. And the fourth one is check constraint and not null constraint. We'll see this constraints one by one. So what is the primary key is? A primary key is a single field or a combination of fields that uniquely defines a record. None of these fields that are part of the primary key can contain a null value. A table can have only one primary key. Okay, so that you should remember, any table can have only one primary key. And another thing is, in Oracle, a primary key cannot contain more than 32 columns. That means you can use composite keys. That means you can combine two attributes and mention that as the primary key. So maximum 32 columns you can combine. Okay, a primary key can be defined in either a create table statement or using alter table also. You can create the table. You can create the primary key. So what is a foreign key is? A foreign key means that values in one table must also appear in another table. And the reference table is called the parent table. Please remember, the reference table is called the parent table, while the table with the foreign key is called the child table. Okay, the foreign key table in the child table will generally reference a primary key in the parent table. So for example, you may have, okay, table 1, okay, as well as you may have another table 2. So if table 2 we have, and in table, okay, so assume that we have an ID called department ID, attribute called department ID. Actually, this department ID, okay, so here this department ID may refer to the department ID, okay, refer to the department ID in table 1, okay. And so while it is referring this, okay, it is referring or referencing, okay, so it's referencing. So DID from T2, table 2 is referencing DID in T1. And in this case, this DID should be a primary key. Okay. And now the DID in this table, we call it as a foreign key. And now T2 is referencing, okay, T2 generally it references the parent table. So actually this T1 we call it as the parent table and T2 is the child table. Okay, T2 is the child table. And next one is unique constraint. A unique constraint, from the name itself you can easily understand that it is a single field or combination of fields that uniquely defines a record. So some of the fields can contain null values as long as the combination of values is unique. So in Oracle, a unique constraint cannot contain more than 32 columns. A unique constraint can be defined in either a create table statement or using an alter statement. You can create unique constraint. And the main difference between unique constraint and the primary key is primary key is also unique. Unique constraint is also unique, but the primary key cannot be null. Okay, the primary key cannot be null. That means it cannot have null values. At the same time, unique constraint can have null values. So what is a not null constraint is attributes defined as not null cannot have null values. That is, the columns compulsorily should contain some values. So for example, if you define a particular attribute called student ID as not null, in that case, while entering value, while you're inserting value for student ID, student ID cannot be empty. Okay, so it cannot be null. Some values has to be entered. And next one is check constraint. A check constraint allows you to specify a condition on each row in a table. Uh, Note, a check constraint cannot be defined on a view, and a check constraint defined on a table must refer to only columns in that table. It cannot refer to columns in another table. And a check constraint cannot include a subquery. And a check constraint can be defined in either a creatable statement or in an alter table statement. Okay. So far I have told you about different types of constraint. What are the different type of constraint we have discussed? I have told you about primary key constraint, foreign key constraint, unique constraint, not null constraint, as well as check constraint. And now we'll see the syntax for creating a check constraint using the create table statement. So first we'll see how to create a table. So the syntax is create table. You have to mention the table name. Okay. Open bracket, column name or the attribute name, then the data type. Okay. Then you have to mention, see, for example, if it is and if it is not null. Okay. In that case, you can mention that as not null. Similarly, the second attribute. Okay. If it is not null, you can mention like not null. And for example, okay, for a particular column, I wanted to define the check constraint. In that case, you have to mention constraint, constraint name, and what is the type of constraint you are going to define? That is the check constraint. Then here you have to give the condition. For example, age should be greater than 18, something like that. For example, for student table, so age should be greater than 18. In that case, check. Okay, then you have to mention the age greater than 18. So that condition has to be mentioned. So like that, you can create a check constraint. So this is syntax for creating a table. So create table name. For example, if you wanted to create a table called student, okay, then you can mention that table name. Or if you wanted to create a table called employee, you mention that. Then you have to define the column name. So column name, for example, if I wanted to have student ID, okay, so data type, it may be number. Okay, then size I have to give, for example, if it is 6. And if it is a primary key, okay, then I have to mention that as primary key. Okay, and the next column, for example, if I say the next column is the student name, and then the data type is varchar2. Okay, data type is varchar2 and the size is 25. And if it is not null, then I can mention that as not null. Okay, so similarly, I can mention the constraints, then close bracket, semicolon. So in that case, your table will be created. And in this example, we have seen how we have created. So here we have created a table called customer details. And with customer ID, we have created as not null constraint. Okay. So here constraint, this n null one is the constraint name. Okay. So this is the constraint name. And then what is the type of constraint we have defined? That is not null. Similarly, customer last name. So this customer ID, okay, so this is one attribute. Then customer last name is another attribute we have created. Similarly, we have created customer middle name, okay, and customer first name. So these are some of the attributes. And also we have account number, okay, and this account number, we have mentioned that as the primary key because that is unique as well as not null. And then we have account type. Okay, so this account type is another attribute. Okay, and this account type we have mentioned that as not null. Similarly, bank branch also we have defined as not null. Okay. And finally, we have another variable called customer email. So these are all some of the attributes that we wanted to have it in the customer table, customer details table. And as I said, what is a composite key is, while here we have created a table called customer details, and initially you know that we have defined account number is the primary key. Instead, assume that if you are using two attributes, okay, in the primary key as a primary key, so that we call it as composite key. If you use combination of keys, okay, as a primary key, then we call that as composite key. And unique constraint actually create table, okay, and then you have to mention the table name. This is your attribute name, data type, constraint name. So this is one constraint, this is your primary key, and this is your not null constraint. And for unique constraint, the same thing, you just mention that as unique constraint. Okay. And implementation of primary key and foreign key. So for implementing primary key and foreign key, actually you need two tables, right? You need two tables. So in this case, actually, we have two tables. One is the project table and the other one is the employee table. Okay. And here actually in the project table, this project ID is the primary key. Okay. Project ID is the primary key. And here actually in the employee table, we have so many attributes in that. This project number. Okay. So this project number is the foreign key. This project number is the foreign key, and this project number. Okay, so here how to mention, how to define a foreign key is constraint name. Whatever constraint name you wanted to mention, that you can give. So here we have given that as F key 1. And this attribute, it references the project ID of the project table. Okay, that means this particular project number, it is referring the project ID of the project table. Okay, and now this table, employee table, we called it as child table, and this is the parent table. This is the parent table. So the project table is the parent table and employee table is the child table. Okay. And also you remember that this particular attribute, okay, that is the attribute which is referenced by the foreign key in another table. Okay, it must be a primary key. So here we have defined that as primary key, right? And implementation of primary key and foreign key constraint self-referencing. Okay, so this is actually within the same table itself, it is referencing. So this is called self-referential integrity constraint. So here in this case, we have a table called employee table. Okay, employee manager. So the in this employee manager table, we have an attribute called employee ID, and this employee ID is a primary key. And we have another ID called manager ID, and this manager ID, okay, so we have mentioned, so constraint name. This particular manager ID, what it does, it is referencing the employee ID in the same table. Okay, employee ID in the same table references employee ID of which table? Employee manager table. Employee ID of employee manager table. So the attribute has to be given within bracket. Okay, and now this type of constraint we call it as self-referential integrity constraint. So now this manager ID is the foreign key. Sorry, this manager ID is the foreign key, and this employee ID is the primary key. Okay, so always remember that actually you can refer a particular attribute can refer another attribute in the same table itself. In that case, that we call it as self-referential integrity constraint. One more thing you should remember, that is when a particular variable is referring to another variable, the data type and the size should be same. Okay, of both the variables. And check constraint, this is an example for check constraint. So here we have an employee table. In this employee table we have different attributes. One is your employee number. Okay, so that we have defined as primary key. Then we have employee name. This employee name we have defined as not null, and employee salary we wanted to have the check constraint. That means while you are entering the employee salary, the salary should be greater than 0, and it should okay, so that value should lies between, okay, so 10 lakhs and 0. So between that value, okay, you can enter. So if you enter some negative value, it will not accept. Similarly, if you enter more than 10 lakhs also, it will not accept. Okay. An implementation of default, for example, while you're creating a table, okay, while we're creating a table for a particular attribute. So here we have an attribute called employee city, ECT. By default, all the values are Mysore. Okay, in that case, you can mention that as Mysore. So what is the default value? So that you can mention. So far, I have told you about create table syntax in different ways, how to create table and how to create constraints. So that we have discussed. And second one is alter command. This alter command, see for example, you have created the table, you have created the schema. After creating the table, if you wanted to do some modification in the table, in that case, we'll go for this alter command. Okay, we'll go for this alter command. So you can add or drop new columns, or sometimes if you wanted to modify, that is also possible. So the syntax is alter table, table name. So which table you wanted to alter, that has to be mentioned. Then you have to mention whether you wanted to add or modify or drop. Okay, that means you can add new columns, you can drop a column which is already there, or if you wanted to modify the data type or the size, that is possible. So here what we are doing is we are adding a new attribute called phone number. So alter table, table name. So here the table name is customer details. To that customer detail, we are adding a new attribute called phone number. Okay, contact phone. Similarly, if I wanted to modify, for example, phone number, the size I have given that is character 10. Instead, if I wanted to change that to 12, I can then I have to use this okay, a quantifier called modify. Similarly, if I wanted to drop a particular attribute name, for example, here contact phone. So in that case, I have to use this drop keyword. Okay. And similarly, you can add constraint as well, right? Using alter command, you can add constraint. Assume that you have already created a table called customer details. Already you have created a table called customer details and you forgot to add the constraint. So after creating the customer table, if you wanted to add a constraint, then use add, okay, constraint name primary key. Assume that while I'm creating the customer details table, I forgot to mention this account number as the primary key. So using alter command, you can add constraints. Similarly, if you wanted to see here also, we are adding this primary key constraint, okay, as a composite attribute. Similarly, if I wanted to drop a particular key, that is also possible. And alter table customer details, okay. And if I wanted to drop, okay, if I wanted to drop a particular constraint, either I can say that drop primary key or I can mention the constraint name. So drop constraint name. So the corresponding constraint will be dropped. Similarly, I can add foreign key. I can add or drop foreign key. So alter table, So here the table name is customer transaction. So for this customer transaction table, what you're going to do is we are going to add a constraint called um, foreign key constraint. Okay. And this account number references the customer details account number. Okay. And later if you wanted to drop that is also possible. Okay, and then truncate table. This truncate table command is used to delete all the values in the table. After creating the table, assume that you have inserted values into the table, and later if you wanted to delete all the values in the table, in that case you can use the command called truncate table. So structure of the table will be there, but the content, okay, that you have inserted, that will not be there. And if you wanted to drop the entire table, in that case, you have to use drop table. Before using this command, you should be very cautious because by mistake, you should not delete, you should not drop a table. Okay. When you use drop, entire structure will be deleted. Okay. And that cannot be recovered. And please remember, okay, all this DDL commands, okay, are not recoverable because it is auto commit. So once it is committed, you cannot roll back, you cannot undo. So before using this particular command, you should be very careful. So for example, assume that we have a table called unique table, and if you wanted to drop the table, then you have to use the command called drop table. You got it? But please careful in using this particular command. Thank you. So with this, the first exercise DDL commands, we have seen different syntax of the DDL commands. Data definition language, I have told you about create, okay, alter, as well as we have discussed about truncate and drop. Okay, we can see how to do that. We'll see the demo of how to implement that. Thank you.